Look up, gaze into the night sky. A canvas of infinite beauty, isn't it? Twinkling stars, distant galaxies, the serene moon. It's a cosmic ballet, playing out over eons. But this dance is not always gentle. Among the graceful pirouettes of planets lurk cosmic wanderers, ancient rocks and ice, asteroids and comets, remnants of creation. They too are part of this grand cosmic design, a design that sometimes intersects with our own path. We live on a precious blue marble, a world teeming with life, a rare jewel, suspended in the vast, dark expanse of space. Our Earth has journeyed through this cosmic neighborhood for billions of years, a silent traveler. It has witnessed the birth and death of stars. It has endured bombardments from space. These are not mere stories but cosmic facts. The universe is magnificent but also indifferent. Its laws govern all, from the smallest particle to us. The silence of space can be deceptive. It seems peaceful, unchanging from our vantage point. Yet it is a dynamic environment always in flux. Recently, the whispers have grown louder. Scientists, our modern-day explorers of the cosmos, are issuing stark warnings, and we must listen. They peer through powerful telescopes, analyze data, they calculate orbits, assess probabilities, and what they are seeing demands our attention. The chances of a large asteroid impacting Earth or even our celestial companion the Moon have reportedly been revised upwards by NASA. These are the highest odds ever recorded for such events. This isn't about fear-mongering, it's about sober assessment, about understanding reality. The universe doesn't care about our hopes or fears. It operates on the principles of physics. And physics tells us that when massive objects collide, the energy release is immense, truly staggering. We are talking about forces that dwarf our comprehension, far greater than anything humanity has ever unleashed. The data streams in, painting a clearer picture. A picture of a dynamic and sometimes hazardous sky. Think about the energy involved. Let's talk specifics about these cosmic titans. Consider an asteroid named 2003 MH4, a significant chunk of rock about 335 meters wide. That's taller than many famous skyscrapers. Imagine that hurtling through the blackness of space. It recently made a close pass by Earth. On May 24, 2025, it flew by our planet. A stark reminder of the celestial traffic near us. A cosmic bullet that, this time, missed. But its presence underscores the ongoing vigilance needed. The energy such an object carries is terrifying. If an asteroid like 2003 MH4 were to strike Earth, the impact energy would be colossal. Estimates suggest it would be equivalent to detonating roughly 1,000 nuclear bombs simultaneously. Pause for a moment and absorb that. 1,000 times the power that leveled cities. This isn't a scene from a movie, it's physics. The sheer velocity and mass combine to create a destructive force of unimaginable scale. And 2003 MH4 is not alone. There's another, 2014 TN17 for example. This one measures about 165 meters across. Section 4. Echoes of Cataclysm. Lessons from Earth's traumatic past. Our planet bears the scars of past encounters. These are not theoretical dangers, they are historical facts. Asteroid impacts have shaped Earth's history profoundly. They have caused mass extinctions, rewriting the story of life. The dinosaurs, rulers of this planet for so long, were likely wiped out by such a cosmic collision. A massive asteroid striking with unimaginable force. The energy released was over 1 million times greater than the Hiroshima bomb, perhaps much more. A stark lesson etched into the geological record. The consequences are devastating, almost beyond words. Massive firestorms could engulf continents. Giant tsunamis could sweep across oceans, obliterating coastlines. The initial blast would level cities, vaporize everything nearby. But the long-term effects could be even worse. Dust and debris thrown into the atmosphere could block sunlight for years, leading to a global winter. This would cause crop failures, ecosystem collapse, a fight for survival on a darkened, frozen Earth. This is the legacy of major asteroid impacts. We don't even need to look back 66 million years. Consider the Tunguska event in Siberia, 1908. A relatively small object, perhaps only half the size of the 165-meter asteroid, 2014 TN17. It exploded in the atmosphere, not even hitting ground. Section 5. Our watchful eyes charting the hazards above. So, what are we doing about this cosmic threat? We are not helpless bystanders gazing passively. Humanity is looking up with increasingly sophisticated eyes. NASA's Center for Near-Earth Object Studies, CNEOS, is at the forefront of this vital endeavor. Along with international space agencies worldwide, they continuously track these celestial wanderers. A global network of telescopes, both on ground and in space, radar systems, and even dedicated amateur astronomers, all contribute to this planetary defense effort. The task is monumental, a cosmic needle in a haystack search. Thousands of near-Earth objects, or NEOs, are cataloged. their orbits are calculated, their risks assessed. But the solar system is vast, and these objects are often dark. Discovering them all, especially the smaller yet still dangerous ones, is a challenge that requires constant innovation. New telescopes like the Rubin Observatory in Chile offer hope for spotting even those tricky asteroids that approach from the sun's direction, our blind spot. But the detection window can be terrifyingly short. This solar blind spot near Venus is a real concern. At least 3 city-killing asteroids, as mentioned, are thought to be lurking in this region. Section 6. Strength in Unity, Humanity's Global Shield. No single nation can face this cosmic challenge alone. The threat of an asteroid impact is a global one. It transcends borders, politics, and ideologies. If a large asteroid strikes, the consequences will be felt worldwide, affecting all of humanity. Therefore, the response must also be global. International collaboration is not just desirable, it's essential. Space agencies, scientific institutions, and governments are increasingly working together, sharing data and resources. This united front is our best hope for planetary defense. We are developing technologies not just to detect, but also to potentially deflect a threatening asteroid. Missions like NASA's DART, Double Asteroid Redirection Test, have successfully demonstrated the kinetic impactor technique. Essentially, hitting an asteroid with a spacecraft to alter its trajectory, to nudge it off course. It's a monumental feat of engineering and precision. Other methods are also being researched, from gravity tractors to laser ablation. The goal is to have a toolbox of options ready. These efforts require significant investment, funding for research, for telescope construction, for space missions dedicated to planetary defense. Section 7. The Human Epic. Charting a Safer Cosmic Future. We stand at a unique moment in cosmic history. For billions of years, life on Earth was subject to the whims of celestial mechanics. Impacts happened, life adapted or perished. But now, for the first time, one species, our species Homo sapiens, has the awareness and the burgeoning capability to do something about it. We can understand the threat, we can see it coming, and we are learning how to protect ourselves. This is a profound shift, a new chapter in Earth's story. The recent warnings, the close passes, the hidden dangers, they are not reasons for despair, but for action. They are catalysts for innovation, for collaboration. Supporting space research is not a luxury. It is a fundamental necessity for a species that wishes to ensure its long-term survival. Investing in science and education and technology is investing in our ability to navigate the cosmos safely. To understand the universe is to empower ourselves to meet its challenges with intelligence and foresight. Stay informed, engage with these topics, understand the science, the risks, the efforts underway. Support initiatives that fund planetary defense, advocate for international cooperation in space. The future is not something that merely happens to us.